Okay, so for this first problem, we want to show that the given function y equals c times e to the 3x is a solution of the differential equation y prime minus 3y equals 0. And unlike in algebra where you want to substitute a number in to show that an equation is true, this time we want to actually take the function and its derivative, substitute those in, and show that they make the equation true. So we're first going to need to get our y prime, and y prime is pretty simple. Again, this first example want to be kind of nice and short for us. So this is 3 times e 3x. And now we're going to substitute this into the differential equation. So it's always good to start off with the equation, which is y prime minus 3y. And we don't know that it equals 0 yet, so you don't want to write that. Instead, what you're going to do is substitute in the y prime that you found above, which is 3c e to the 3x. And then, of course, the minus and the 3 are part of the equation. And then the y, we know, is going to be c times e to the 3x. And now that we see that we have two exact like terms, we know that something minus itself equals 0. And we have verified the equation. So again, you'll notice that we started with a left-hand side and showed through a chain of equals that it equals the right-hand side. The next part of this is to solve the initial value problem. And again, that was y of 0 equals 2. So this requires us to substitute in 0 for x and set the value of the function equal to 2. So if we have c times e to the 3 times 0, that's equal to c, and that requires c to be equal to 2. So the solution of the initial value problem is actually y of x is 2 times e to the 3x. For the last part of this now, we're going to go through and state the interval of existence, sometimes abbreviated as just interval of existence like this, or sometimes just IOE if you really want to abbreviate it. And to find this, you want to take a look at your original function, which is above, our 2 times e to the 3x, and ask yourself, when is this function ever undefined or ever not differentiable? And because it's just a simple multiple of an exponential function, you'll notice that it's always continuous, and it's going to always be differentiable as well. So because of that, the interval of existence is going to just be all real numbers. And that means, of course, if you were to graph this function, it would pass through the point 0, 2, and it would be a nice graph that extends to the left and the right. Okay.